Hi everybody, Mrs. Bowen here. We're going to take a look at Learning Target 4.4. I can write equations of parallel and perpendicular lines. And in this video, we're just going to look at parallel lines. So let's start with, what are parallel lines? Well, let's sketch a real quick diagram here. Here would be an example of parallel lines. Parallel lines will extend forever in both directions, but they will never touch, or they will never intersect. So I'm going to make a note here, they never intersect. So that means if you're thinking about parallel lines, as you consider their rise over their run, or how much you're going to move up and down versus how much you're going to move left or right, they have to be the same, right? The rise over run has to be the same. So we could say slopes are equal. Parallel lines have equal slopes, so slopes are equal. And we'll make one last note that while the slopes are equal, the y-intercepts have to be different. Let's say y-intercepts are different. Let's think about that for one moment. Why do the y-intercepts have to be different? And the reason they have to be different is because if they have the same slope and the same y-intercept, or if they have the same m and the same b, then they're just the same line. So they can have the same slope, but they do have to have different y-intercepts. And I'll put here in parentheses, I'll say otherwise they would be the same line. Otherwise they would be the same line. So they're two different lines. Parallel lines have to be two different lines, but they have the same slope, but they start at a different y-intercept. All right, so for part A, again, this video is just covering parallel lines, and our directions tell us to find the slope of a line parallel to each given line. And so here for my warm-up, I am given a line. And if I'm asked to find the slope, for slope we said the universal letter is m, so my answer is going to be m equals, because I'm finding a slope. So if I need a slope parallel to this line, we just need to find the slope from this line, because parallel lines have equal slopes. So remember, your slope is always the number that you have in front of x. This is in the form y equals mx plus b. So as long as it's in slope-intercept form, my slope is the number in front of x. So my slope is -4. My second warm-up, it's already in slope-intercept form. So again, my slope is the number we see in front of x. So my slope is 1/2. For my last warm-up here, my equation is not in slope-intercept form. So I need to move this equation to be in slope-intercept form. I need it to be in y equals mx plus b. So the first thing I need to do here is move this x to the other side. So I can do minus x on both sides. And I'll get -3y equals -x plus 9. Review here. Notice I'm not combining the constant 9 and the -x, which is a variable term. We cannot combine those, so I'm keeping them as they are. I'm choosing to write the -x term first and the constant 9 term second, just so it can be in our slope-intercept form, y equals mx plus b. My last step here to get y by itself is to get rid of this -3 that's being multiplied by it. So to undo multiplication, I can do division. So I have to divide by -3 on every single term. And so then I get y equals, here I'm doing -x divided by -3. That's like saying -1x divided by -3. -1 over -3 just turns to +1/3 x. And then 9 divided by -3 gives us -3. So here's the equation in slope-intercept form, and we were asked to find the slope of a line parallel to this line. So that means the slope has to be equal. So if our slope here was 1/3, then our m would have to be 1/3. So we will use this knowledge that parallel lines have equal slopes when we jump into our first example. Example 1 says, write the slope-intercept form of the equation of the line described. And I am given a point, x comma y. We can make a note to remind us, this is always x comma y. And it's parallel to this line. And so if I'm going to have to write slope-intercept form, let's first just jot down, remind ourselves, slope-intercept form is y equals mx plus b. And when we're looking at this, there's two unknowns, or there's going to be two variables that we have to find. We have to find our m and we have to find our b. So we have to know what's our slope and what's our y-intercept in order to come up with a line that's parallel to this line. Keep in mind the y and the x are part of your form for slope-intercept form, and these here are two unknowns. So first let's find the slope. That should be quick, right? If our slope has to be equal to the slope in this given line, then we're just looking at what number is in front of x. And again, we said parallel lines have equal slopes. So my m here, if here I see a negative in front of the x, that's like saying negative 1x. So my slope has to be negative 1. So this means right here, I found one of my unknown pieces. I found that my slope is negative 1. So now I know my slope. The only other piece I need to find in order to write my final equation is what is my y-intercept, or my b. So I know the m, and somehow I need to be able to plug into this form to find b. Notice I was also given this point, x comma y. So what I can do is plug this x value in for x, this y value in for y, and our slope that we know in for our slope. So again, my y is coming from the ordered pair. Y is 1. My m, we said it was an equal slope, so it has to be negative 1. This is m times x, so negative 1 times our x value that comes from our ordered pair, which is negative 1. Notice, because this is multiplication, I did parentheses here, m times x, so negative 1 times negative 1 in this case. And then I have plus b at the end, which is good because that's our variable. The variable we're solving for here is b. We need to find our y-intercept, or our b. So now I can simplify this. I see some multiplication that I can take care of. So I'll write 1 equals, and if I do negative 1 times negative 1, that turns to a positive 1 plus b. And now I'm very close to having b by itself. The only thing that's in the way is this b plus this positive 1. So I need to move a positive 1 over to the other side. And the way I can move a positive 1 to the other side is by subtracting 1. So then I'll have b by itself, and I'm doing 1 minus 1 to get 0. So here's my other unknown. Right, I had two unknowns. I had to find my slope and my y-intercept. I know my slope had to be equal, and I just found my y-intercept. So now that I know both of these pieces, I can plug it into my slope-intercept form. So looking at my slope-intercept form, y equals mx plus b, I just have to plug in my m and my b. So I have y equals, my m is negative 1, so negative 1x, plus my b, which is 0, plus 0. It's kind of silly to write this plus 0. So it's unnecessary to write that, right? You also don't have to write this 1. Instead of saying negative 1x, you could just say negative x. That would be fine too. So here would be our final answer. Y equals negative x. Because again, we don't need to write this plus 0 at the end. All right, now let's jump to example 2. So on example 2, again, I'm given a point, and I know that I need to find an equal slope because these lines are parallel. Parallel lines have equal slopes. So right away I can look at this and say, all right, my slope has to be the same as whatever's in front of x. So my slope has to be negative 1/2. I can write my slope-intercept form here. Y equals mx plus b. And we have two unknowns, or two pieces we have to find, our m and our b. And I already found one of them. I found that my m is negative 1/2. And now I can plug in my m. I can also plug in the x and the y for my ordered pair. So my y comes from the ordered pair. It's negative 1 equals, my slope is negative 1/2 times my x, which comes from the ordered pair. It's negative 2. And at the end I have plus b, which is good because this is the variable that we're trying to find. I can take care of this multiplication. So I have negative 1 equals negative 1/2 times negative 2. Or you can think of this as negative 2 over 1 if that's helpful. And hopefully you're seeing here that the top and the bottom of your fraction here, it's going to cancel. And negative times negative is a positive. We do get a positive 1 here. You can also use your calculator if that helps you, if you're struggling to deal with this fraction. Negative 1/2 times a negative 2 gives us a positive 1. We get plus b. We now need to move this positive 1 over to the other side, and we can do that by subtracting 1 from both sides. And I'll be left with b equals, I'm doing negative 1 minus 1, or I get that b is negative 2. So here was my second unknown that I had to find. So I found my 2 unknown pieces, and now I just have to plug them into my final equation. So y equals mx, my m is negative 1/2 x, plus my b, which is negative 2. And I'm not going to write plus a negative 2. That would be silly to write plus a negative. So I'll just go ahead and write negative 2. And so there would be my equation. And again, this equation is slope-intercept form of a line that's parallel to this line. Notice they have the same slope, negative 1/2. It's parallel to this line, and it's going to go through this point on our graph. All right, at this time you have one you try to do. So go ahead, pause the video and see what you come up with. Let's see how you did. In this U-try, my slope had to be equal because they are parallel lines. Notice that there's no number in front of x, that means there's a 1 there. So my slope is 1. I plugged in my ordered pair, x comma y, and I was able to get that my y-intercept, my b, is 3. You had to be careful right here where we had negative 1 plus b on the same side of the equal sign. And we're trying to move a negative 1 over to the other side. So the way you move a negative 1 is by adding 1. So be sure that you added 1 to both sides. And that's how we get that b equals 3. And then my final step is to write my final equation in slope-intercept form. I plugged in my slope of 1 and my y-intercept of 3. And notice I wrote it without the 1 in front of x. It's not necessary to write 1x. You can just write y equals x plus 3.